Okay, students. So last time we discussed, we stopped over here when we were going to discuss about the state of the art. So we saw the state of the art means that what is the current latest development that is happening in this area. So normally this word is used a lot in the research domain, which means that what is happening recently in this area. So state of the art in computer vision means that what is the latest thing, latest technology that is happening in this field. So uh, the question that comes is that are the computers, they are better in vision than as compared to human? So the answer for this is that mostly they are not better, no. But in some tasks they are better because those tasks are very easy but repetitive. So the difficult tasks, human vision is better in difficult tasks. So what are difficult tasks? Difficult tasks are like uh, seeing a shadow in the water. That's a hard or difficult task. Okay, and some other things you will see we will discuss in the future. And the easy tasks which are repetitive are like, for example, surveillance, to detect if there is some object moving in the image, to detect the human face in the image. These things are easy to detect for the computer programs, and computers are better in this because computers, they never tire. So they can work 24 hours, they don't get sleepy, they don't get tired, they don't get bored. So this is the background. So we will discuss now state of the art. The slides that you see over here, they are a little bit old. So this state of the art has also changed in the last 3 or 4 years. So it will just give you an idea, but it's not perfect. One state of the art you see is in 2005. Okay, so 2005, this was, so 2005 is not so old, 2003 I think, but in 2005 it became practical. The first work was done in recognition of characters. So handwritten characters were recognized by the computer algorithm. So it was first major machine learning, computer vision achievement. So for example, if someone writes an O like this, so human writing, it's not perfect. Sometimes you don't write it completely circular. So still it is able to detect it as a zero. So over here you see this writing over here. This one is the human written, and this over here, the zero that you see, this and this shows what is detected by the computer vision algorithm. So this was a work done by AT&T Labs, very famous labs in America, and they did this work in 2005, and it was called LoudNet. Okay, and they detected it so perfectly that it was implemented later on to detect handwriting on the letters written, posted into the United States Postal Services, USPS. Okay, and just in 10 to 15 years now, this recognition, hand recognition, you can say the character recognition technology is so common that it is now available in very commonly. Muscat Airport, it has got this character recognition. You enter with your car into the airport, and you, if you want to go outside the parking, you have to produce the same uh, parking ticket that is issued for that car. You cannot try with another ticket. It will detect the car number and automatically it will only allow that car to go. Similarly, even over here in the police crossing at Wadi Jizi, there also they have this character recognition technology that when the car comes, it automatically detects the car number and it gives this number on a printed slip to the police officer. So these things, they have become more common and they are very, very useful. So common application of this is handwriting recognition on or the number plate of the driving car license number plate reading. Some other technologies that have become very common and they are around us all the time. One technology you all know, all of us carry mobile phones with us. So mobile phones, and before that in the cameras, there was technology that camera can automatically detect the face in the picture, how many human face are there. So it can easily detect in the picture how many human face are present, and it will make a circle or a square around that human face. So face detection is another feature that came initially for digital cameras, but it's available by default. This is a program, this is a software, it's available already for the camera on your mobile phone. Something more newer in this area came. It was by the Sony. So the Sony company, it provided some new technology and they created some software that they called as Smile Shutter. So what they do is with the Smile Shutter is that the software will detect that in the picture if the eyes are closed for any person and if the person is smiling or not. So maybe sometimes it happens that you can make the setting that when the camera will take a click or a photo, it makes sure that everyone is smiling and no one's eyes are closed. Clear? So this is another application. Another very common application of this computer vision is the face detection. So face detection, where it happens? It happens on your Windows computers. It can use your webcam to detect the face and allow the user to use the computer. So the login occurs with the face. But more common than this is the iPhone. So in the iPhone, if you all know, in the case of iPhone X, I think, it has this feature that instead of thumbprint recognition, it works based on it works based on the human face recognition. So when it is when the software is trained on the human face, it will open only for that face. It will open the interface. So that's also a cool new technology. So this technology is not so old. Hardly 2 to 3 years ago it came. This is now another application of computer vision. Now this application shows over here a very good idea that was produced by some students who were graduate students, master's level students in USA, who created this idea. So what they did is that they developed, so they created a company. So this was their project in the master's level, graduate project, and then they later on converted this project into a company project. So they created a company after the masters. They called this software LANHawk. And what they do, first listen to this. What they do is that, for example, you go to a big supermarket like a Carrefour or a Lulu, and over there when a person is going outside the shopping center with their trolley full of many things, so what happens is sometimes when the person put all the items on the cash counter, so on the cash counter they put items, sometimes it happens they forget something, maybe under the trolley. So what will happen with these things that are under the trolley that are left? So for this, they And remember, in the US, the labor is very expensive. They cannot hire too many people for this task only. So they made a technology that they installed over there. They asked those superstores to install a camera that will focus on the lower part mostly of the trolley. Okay, and what it will do is that this camera detects that if the trolley is empty or not. If it is not empty, it will just make an alarm. So this was the idea, and it was very successful, and this company became quite bigger, the idea, and 5 years on it was hired by another big company. So you see, the things they have developed in this area not so old. In the last 15 to 20 years, most of the things have occurred in computer vision. One more thing was Google Eye, if you remember. So Google Glass or Google Eye, it was sunglasses, not sunglasses, it was like normal vision glasses that had a separate camera on the side. And what they do is that they capture whatever the human is looking at, and they will translate it in terms of description. They will describe whatever is in front of the camera. So maybe the camera looks, says that this is a sofa inside the room, or it will say that now we are outside and there is sunlight or there is raining. So all these things, many such things, they could be described by that algorithm and the camera. This is a very important application for those people who have some sort of blindness. So for the blind people, it is a very good application. It helps them to feel what is around them. Another aspect, so this was mostly for detecting some object and try to do something with that object. Another thing, another area of computer vision is related to graphics, to produce something. Now this area is more related to computer graphics, not too much to computer vision, but still we will discuss here that we have special effects. For example, in the movie, so here they show a movie Matrix, where they wanted to show one same person. He was like a virus and he had same copies, all of them are same. So they did this using the computer graphics. One more application. Now this application is not for graphics, this is for computer vision. So this is another movie, Pirates of the Caribbean. And in this movie they wanted to show this character. So this person with some dwindling things on his face. So this face, how they do this? Do they create a mask for this thing? No. Mask is really difficult to carry all the time, and it's not easy for a person to speak while they have such a big mask. So practically how they do this thing is that the person who is the actor, he is speaking, and at that time he has these marks on his face at important points. So marks are normally, for example, in black and white color, or maybe blue and white color, but they are usually in two different colors. And what happens later on, these marks that are on the face, they are captured by the computer program, and program or the algorithm, it will convert that face into this face automatically. Detect the exact location where it should put some extra graphics. So this is how it works. So it's the application of computer vision. Another one, this is more towards the graphics side. So we discussed, I think last time also, that in Google Earth you can create 3D models. So 3D model basically means that you take many 2D images and from those 2D images you try to create a 3D model of some area. For example, you see this sheep, you can feel how thick it is, how tall it is, and what it looks like. Okay, so this is created with the help of many real 2D images, and they create model like this which looks like real. Clear? One more application are the smart cars. This is something still in a research phase. So Tesla, they are working on this. There are some other companies who are trying. What they are trying to do is that they put a lot of sensors in the car, cameras and other sensors. So for example, here you see lots of cameras. All these are cameras. Okay. Other than camera in the car, they also put something called a special type of radar called as LiDAR. So LiDAR, I think there is an A, L-I-D-A-R. So LiDAR is a device. If I don't remember, if you have seen those autonomous cars, those cars that don't need a driver, those cars normally have something on the top that is circular and it is rotating all the time. That rotating thing is LiDAR. And the job of that thing is to detect if there is some person or some obstacle. So it's like a radar. Other than radar, there are cameras, a lot of cameras in the car, and the cameras, they are trying to detect what is in front or in the sides or in the back. So for example, the camera detects this image, and from the image it also detects what is it. So it finds out easily that these are humans. All of them are humans. Clear? So this was one other application of computer vision. So same thing here, smart cars. So this is the LiDAR. You see, I discussed, this is LiDAR. So there are other cameras also, but these are the radars. They all help for the car to drive. So here you see another car. This is also autonomous car. And these cars can perfectly drive on most of the roads that are properly structured roads. Unstructured roads, no. Structured roads, they can easily drive. So remember the technology, how fast it's changing. Maybe you can expect after 10-15 years, maybe you will have many cars on the roads like this without driver. Or maybe it will be so common that everyone will be using these cars. There will be no concept of driving in next 10, 15 or 20 years. We don't know. Here is another example of use of computer vision. Here is the use of computer vision in American football. So American football is the rugby. It's a game just like football, but the main thing is that they take the ball in their hands and they run until the other person tries to stop them. So just like in the football, when you most of you normally know the rules of the football. One of the rule of the football is that the player from, for example, if this is A team and this is B team, the player from the A team, if he don't have the ball, he cannot cross the player of B team. So if this is the player of B team, A team player cannot be at this location if he don't have the ball. If he has the ball, no problem. But if we don't have the ball, then in that case, he will be called as offside. And that's a foul, and they will not allow him to play like this. Okay, but if he has the ball, no problem. He can directly go to the goal. So same rule over here. And what is the use of computer vision here? Computer vision detects the two teams and it will try to create this artificial line. So the line that you see over here, this yellow line, this is not real. This is an artificial line that is created by the computer based on its idea what is offside. So it is helping the umpires, and it is also helping those people who are watching on the screen that what is the offside line and if the person is doing bad or good. Clear? One other place where a lot of computer vision is used is the computer games, interaction based computer games. Maybe most of you have heard these names of like a Nintendo, like Xbox, or like Sony PlayStation. These are the devices that are used for computer games. Okay, so in these games there are some new features that are quite helpful they give a unique experience to the users, and they are based on computer vision. For example, the Xbox 360, it has got 3 cameras, and it allows the users in front of the TV screen, with the help of these cameras, it allows the users that they can play the game using their movements or their hand gestures. So for example, over here they are moving the hands, and that movement is causing the car to turn. So the hand movements are detected by the software using these cameras. Clear? So these are the common uses, and some of it we will also see over here. You see the camera detects the person that is in the front of the camera and that is in the background. Clear? Here is another use of the cameras. This is what I discussed earlier. This is the most common use in surveillance. Surveillance means to monitor. So surveillance is a very common idea. Many important buildings, airports, hospitals, some other places, they have those cameras. Those cameras, they are used to check specific areas. So when a human is sitting somewhere watching that area, human maybe they can miss some important details, or maybe they are not sitting on their seats all the time. So for this purpose, computer vision based algorithm or software will be very efficient, and it can easily detect humans everywhere in the screen. Some uses of this computer vision in medical. Here is an example of medical, where you see over here that the human brain, so you see over here the MRI. So MRI is a process, medical process, which is same as CT scan. So in the MRI or CT scan, they try to scan the, mostly it is done for the brain, and it is used to scan the brain for any problem, to detect any problem. So these are examples of images which are interpreted using some sort of programs or algorithms. One more example is image guided surgery. Now it is also becoming very common to help the doctors using the computer and technology. That for example, doctors have to do some brain surgery. So this example is from MIT. So what they happen is that they will cut open the human head for operation. So they use some sort of imaging of the internal organs. They will produce the image that what type of parts are below this area, and that image is projected on the head, and then the doctor can make a cut and do the surgery. So this is only that is happening in the last 5 years or 10 years. So just imagine what will happen 10 years from now. So this area is changing very, very rapidly. Many things I told you, these slides are 2 or 3 years old, so many things have changed. Now we come to the other question, why this area is difficult. Quickly I ask you, you can pause the video here. This is interesting question I ask in the class. You see over here 2 points A. So here is A and B. Which one is dark color and which one is light color? Okay, quickly. You can pause the video, think over it. So most of you, they will reply back that A is darker and B is lighter. Yes or no? Okay, so one of them is dark and the other is lighter. But if you take some sort of strip and you try to find it out, you try to compare, you will see that A and B are basically both same colors. No difference at all. Clear? No difference at all. So what is happening again? Look carefully. Basically what's happening is that there is a cylinder over here, some shape, and the cylinder is casting some shadow. There is a shadow. Because of this shadow, all the things over here have gone darker. So the dark area has become double darker. So this is double dark, and the light area has become a little bit more darker. So this light area is same as this dark area. So the A is same as B in terms of brightness. So practically if you take the pixels in area A and B, they will have same value, 100% same value. But just see, our brain, it can feel it very easily that B is lighter and A is darker. Practically they are same. Now this is a big trouble. How computer vision will do this? Now this is not easy. That's one of the reasons computer vision is difficult. Clear? So in the previous example, the two squares, they have exactly the same measurement. If you consider A and B in terms of measurement, they are same. Measurement of intensity or brightness. So seeing is not the same as the measuring properties in the image. So seeing is not as if you are measuring it. Seeing will give you, the human vision gives a different picture. So basically when we see something, seeing means that you try to build some percept or feeling. So percept means feeling. Build a percept of what is in the world based on the measurements made by the imaging sensors. Clear? One more example of computer vision. Here what you see, if you remember, all of you, just imagine in, I don't know if you remember or not, in 1990s or until 95 or 2000, many people who used to go to Hajj, they used to bring a small device from there. Normally it was in orange color, if I remember. It was a small device that contained some images for the places over there in Makkah Mukarramah and Medina Munawwara. So it used to bring people who go to Hajj, they bring those photos from there in those special discs. So discs were there that had those photos. So what was the purpose of those photos, if anyone knows already? So the purpose of those photos was that device, when you place that device in front of your eyes, that device created a 3D image, not a normal image. You will see those places as a 3D. So what is the difference between 3D and normal seeing? In 3D images, This is what happens in the cinemas also. When you go to the cinema, you want to watch in the cinema, you want to watch a 3D movie, they will give you a small pair of glasses. If you remember, they give you a plastic glasses, small. Have you seen it or not? One part of the glasses is, I think, in red color, and the other part, I think, is in blue color. Different colors, not same. Okay. So, did you ever thought why people have to wear this funny looking glasses with different colors, red and blue? So the reason for this was because of those two different colors, the two different eyes, the left side eye and the right side eye, were shown different images. So for example, here you see the eye on the left and right is shown a little bit of different image. So when a little bit of different image is shown, the human brain tries to create a 3D image. So here it is. Look carefully. This is the left image. This is right. Left, right, left, right, left, right. So what's happening? There is a little bit of difference. This difference between the vision of left and right eye, it gives our brain the feeling of the 3D, the feeling of the thickness. So what is the thickness of the objects? This is how our brain works for 3D images. Clear? So devices that you see like over here, this is the same device that people used to bring from at that time from the Hajj. Clear? Here is another example. So you see over here, I don't know if it runs or not. This website, you can go on this website and you will see over there and the description. Let me try if it works. So let us go to this place. So if you open this website, on this website you will open a small example, and that will make it clear to you that why the 3D is difficult. Why the computer vision is difficult? Because of the tricks in 3D. So let's see if this internet works. So here it is. So two examples are there. So it will download. And let's hope it works. Okay, the last part of this video, you see over here what's happening. I will play it myself a little bit slow if I can. Why it does not allow me to go back? So you see, look carefully. In this image, you observe a green box that is moving up or down. Okay, green box is moving. So this is a green square, you can say, that is moving up or down in the air, for example. Now look carefully again. Practically look if the green box has moved physically. Is it moving? So you will see that practically the green box is not moving at all. It's stationary. You see, the point are same. The only thing that is moving is the shadow of the green box. So the shadow moves, and this shadow creates the feeling as if this box has raised up in the air. Now this is a big trouble. The green box does not move even 1 centimeter, does not move at all. Still our brain gives us the feeling as if this box has moved up in the air, only because of the shadow that is on the sides. Now this is a big trouble, not easy to deal. Another example. This is another example of a ball. Now this ball, same idea over here. You will see that this ball is moving, and then you will see that as if this ball is flying. So which one is correct? You see this ball is moving now. Moving. Now you will feel as if it's flying. But carefully, if you look again at this video, the ball itself is moving only. Let me choose a resolution that's not destroying. So carefully look now. The ball is moving only in the same exact location. Ball has not changed its path at all. Okay, but the feeling that's changing, it's because of the shadow. If the shadow moves along the ball, we feel as if the ball is on the floor. Okay, now it is on the floor. But if the shadow moves away, we feel as if the ball is flying in the air. Now this is a big trouble. Just imagine for computer vision, how computer vision can give a feeling as if the ball is flying. But practically it's moving on the same direction, on the same location. Okay, I hope the idea is clear. Now this is the thing that is in the computer vision, it's difficult. So interpreting the images is a very difficult thing. The human system, human brain system, it gets the wrong feeling. Nothing is moving practically upwards in the case of box, but we feel as if it is moving up because of the shadow. Now that is this thing, how the computer vision can feel in the same way as the human brain feels. Okay. So this was about state of the art, and then those the problems that we have seen, why computer vision is hard. Now we will see the final thing, what you can expect in this course. In this course you will see or expect three things. Three main things for every topic we will cover. We will see the models, mathematical model or any type of model or theory about any task in computer vision that we discuss. Okay. Then the second thing we will see is that model, it is converted into some algorithm. So algorithm is same thing as program. Okay. This algorithm initially we will develop it ourselves, but later on we will be using the library, OpenCV library. Okay. We will discuss what is OpenCV, we will discuss at that time. So first thing is the model, the theory, the mathematics. Second thing is the algorithm or the program. And the last thing we will discuss is that we will apply these things, this algorithm, we will use it on the real images. So in terms of real images, we will see two things. One thing is called as the image, is also called as the scene. This we discussed last class also. Image is also called as scene. There is another thing sometimes which is called as ground truth. Ground truth means that what is practically expected, what is the best output. In this case, I want to get the image depth. Image depth is a concept where we want to find out what object is in the front and what is in the back of the image. Okay, what is near the camera and what is far from the camera. So the ground truth in this case is that these objects that are bright color, they are in the front, and those that are in dark color, they are in the background. So three things we will cover mostly in this course: computational models, algorithms, and real images. Clear? So this is our introduction to computer vision. So not all of these topics we may cover. This course overall is very advanced. A lot of things will are for the graduate level course. Clear? The software we will be using over here will be Python. We will also be using two libraries in Python. One is NumPy and other is OpenCV that we will be using. We will discuss them in the lab work in more details. So I hope you will learn a lot from this course, and I will see you all in the next lecture with lab details.